How are you all? Hope everyone is fine and safe. Okay, so in the previous video, we have done about the trigonometric ratios of the complementary angle. In this video, also we'll be continuing the same problems of that exercise 11.3. And before we move on to the next problem, we'll first revise our formulas. The main key to success is the revision. I always prefer that, and I really urge you people to take a small handy book and write all the formulas. Keep that book as a formula book itself. Okay, that will be very easy for the quick revision. Since trigonometric ratios have so many formulas, it will be very easy to just go and refer it. Okay, now let's revise trigonometric ratios of the complementary angle. What is a complementary angle? The angle which is like one of the angles opposite of the angle is the complementary angle. We know that in our triangle, the angles will be like overall angle. The sum of the angles will be 180 degrees, right? So we already know that since we are doing the trigonometry, there will be a right angle triangle. We already know that one of the angle is 90 degrees, right? 90 degrees. So here in the leftover angles, one of the angle A we take as a main angle, and angle C that is complementary of A angle, with the sum of both will be 90 degrees, right? So it's nothing but one of the angle, complementary angle, is nothing but 90 minus the main angle. Here angle A is given. Since we are talking in terms of theta, we'll be taking as angle A as theta, this angle as a theta. Now we will be finding out another angle. Another angle will be nothing but 90 degrees minus theta. So you got this value how we are getting 90 minus theta, right? Okay, now how to get the ratios? We know the ratios: sine theta, cos theta, tan theta, cot theta, secant and cosecant, right, side by side. And again, what you need to do, you know that 90 minus theta is there for the complementary angle. You just need to get click to it. Okay, now sine is converted to cos, the next ratio. Okay, the same thing goes here. Cos converted to sine, tan converted to cot converted to tan, secant converted to cosecant, cosecant converted to secant, and these angles theta is converted to 90 minus theta. Okay, here in everywhere theta is replaced by 90 minus theta. I'm just telling this trick to just remember the formulas. It's not the derivation of it. Okay, now see, all the sine, tan and secants have like in their answer as cos, cot and cosecant. That is co. The co is common in all that things. You can remember the exam. Just for cross checking that you're going in right direction. Okay, this is the trick to remember. Okay, the same thing, cosecant and all, you're just changing, converting it into opposite angle. Okay, 90 minus theta. So this is the relationship between cos and sine theta for the complementary angle. Okay, now let's quickly move on to the second bit. The revision is done. We'll be moving on to the second problem of 11.3 exercise. Okay, the second bit is show that tan 48 degrees into tan 16 degrees into tan 42 degrees into tan 74 degrees is nothing but 1. So generally when there's a show that problems, we'll take this as left hand side and this as our right hand side, and at the end we need to prove LHS is equals to RHS. Right, simple. Now see, in this problem also, like previous problem which we have done in the previous video, the last bit, here all the things are in terms of tan and tan. Okay, so in that case also it's a big problem, because we everything should be like, even it's a tan, this should be equated. I mean, almost it should be similar, so that we can cancel easily and get the value, right? So this should also be same. So now what we are doing, we will keep two terms in the same way and another two terms will be changing. Now let's see how we can get that changing term. Okay, let's see, 90 minus 48. What is, let's take this one first. 90 minus 48, what are we getting? Okay, what we are getting, see, we are just taking one of the angle. Okay, 90 minus 48, what are we getting? 42. Okay, so we can establish some of the relationship between these two angles, right? Because the angle, I mean the theta's value is almost like complementary, seems complementary. 19 minus 48, nothing but 42. Okay, we can establish relationship between these two things. Next we'll see, like if we can establish a relationship between 16 and 74. Okay, 90 minus 74, either way is 19 minus 6, 90 minus 16 is 74, and 90 minus 74 is nothing but 16 degrees. So we can establish relationship between these two things, right? So now what we have to do, get it collectively. Okay, tan 48 degrees into tan 45, tan 42. Okay, into anyhow it's all it's not a subtraction or addition, it's multiplication, so it should be easy to move any of the character here and there, I mean the term, into tan 74 degrees, right? We are just getting the common things here together. Since they have something common, we're dividing accordingly. Okay, then will be taking the highest one and changing that value, right? So tan theta, we know that tan theta is nothing but cot 90 degrees minus theta, right? We know this value. So here in what is tan theta, what is theta here? 48 degrees. Okay, so cot into 90 degrees, what is theta? We got as 48 degrees. So answer will be tan 48 degrees will be nothing but cot 90 minus 48 is cot 42 degrees. So we will be writing it here. Okay, we will be writing this value in tan 48 degrees, right? So cot 42 degrees into tan 42 degrees. Okay, this is the same thing that we are doing. Okay, and herein we know that the same thing applies here. So tan theta is equals to cot 90 degrees minus theta. What is theta here? Tan, we are taking the highest value, tan 74 degrees into cot 90 degrees minus 74 degrees. So tan 74 degrees minus what is cot 90 minus 74? We just got 16. Okay, cot 16 degrees, right? So this value is, we are changing here this value as this. Okay, into tan 16 into cot 16 degrees, right? Now you see they are like terms are different, cot, tan, cot, but the only comfortable thing here is that the angles are same, the angle reduced to the same thing, right? Now you can easily, convert this cot into tan. Again, if you use complementary angle, we'll land up getting the answer as tan 48 only, right? Obviously. Next, so what we can do is we are changing the value of cot to tan. How it is? We know that cot theta is nothing but 1 by tan theta. So we are just replacing the cot values with tan. 1 by tan 42 degrees, right? Into tan we are keeping 42 degrees, not 420, sorry. And here in tan theta we are keeping it as it is, tan 42 degrees into tan 16 degrees. Into what we are doing? Converting cot into tan 16 degrees, right? Sorry, tan 16 and 16 degrees. Now it's simple, since it's a multiplication. Tan 45, tan 42 degrees, tan 42 degrees cancel. Tan 16 and tan 16 ones, the answer is 1. So hence proved. LHS is equals to RHS. We just got the answer, right? Wasn't it simple? Okay, for some people, if it's like difficult step, don't understand the cancellation part. Again, for them, I'm adding that tan 42 degrees into 1 is tan 42 divided by tan 42 degrees into tan 16 degrees divided by tan 16 degrees. Tan 42 1, I mean tan 42 degrees, and this tan cancel, tan 16 and tan 16 cancel. Answer is 1. Since it's a multiplication, you need to be very careful with signs, multiplication and addition or subtraction. That will be, changing the game. Let's move on to the next bit. Okay, we have to show that cos 36 degrees into cos 54 degrees minus sine 36 degrees into sine 54 degrees. Let us first take like 90 minus, let us take this. 36 is nothing but 54, right? So here and also there's like same angle, 36 and 54 relationship. Okay, we are just establishing it. So here and we know that we can easily convert the angles, right? Now here and we know that it's a cos minus sines. Now what we do is we will be changing this, let us take the highest this thing. Okay, let us first copy the given value. Given is cos 36 degrees into cos 54 degrees minus sine 36 degrees into sine 54 degrees. Okay, we are not just giving it equal to 0. That's a statement that we need to prove it. Okay, So we know that using the formula cos, like we are taking what I said, we are taking the highest value, okay? Cos theta is nothing but sine 90 degrees minus theta, which is nothing but in our case cos theta is what? 54 degrees is equals to sine 90 degrees minus 54 degrees, right? Okay, so cos 54 degrees is equals to sine 36 degrees. Okay, now what we'll do, will be substituting, we'll be trying to substitute here, but you see it's not the division or multiplication, so that will be just doing and just cancelling. Here then you need to carefully check that this is cos, this whole thing is sine. So what we can do, one more thing, and the the best part is that the angles are relatable, 636 and 54. Now what we can do, because this has sine values, we need to get all these things in one term. What we will do, we will change this cos 36 degrees also. So one of the value we got for cos 54 degrees is sine 36 degrees. And another thing, we also know that instead of 54, it is 36 degrees now. 36 degrees is nothing but sine 90 degrees minus 36 degrees. Cos 36 degrees is nothing but, I'm so sorry for the handwriting, sine 54 degrees, right? So we got these values like cos 54 degrees in sine term and cos 36 degrees in cos in sine term. This is sine, this is sine, easy to get the answer, right? So substituting in given value, what we are substituting, these values, these two values we are substituting in the given value. What is given value? First we'll copy the given value so that in exam it will be no confusion while copying. So instead of cos 36, what did we get? Sine 54 degrees. Instead of cos 54, what did we get? Sine 36 degrees minus sine 36 degrees and sine 54 degrees, right? So it's nothing but like swapping the things. It's simple. It's nothing but 1 into 2 minus 2 into 1. Okay, that way. So what is the answer for this? Answer will be like, it's nothing but 2 minus 2, right? It's nothing but one value minus the whole value. Answer is 0. Hence proved. We have already proved that LH is equals to RHS. Let's move on to the next problem. Okay, third problem. If tan 2a is equals to cot a minus 18, 2a is an acute angle. I mean, this angle is an acute angle. It's showing that it's a complementary angle thing. Find value of a. Now, see, let us copy what are the given aspect. Given it is like tan 2a is equals to cot a minus 18. Now first we need to, what we need to do, we need to establish a relationship and get these both things in one term. Okay, for getting that, in these problems you can take anything to convert cot to tan or tan to cot. What we'll do is we'll take as we will take as an angle of changing the tan value. Okay, so because since it's like a complication, it has complication of a minus 18 and all, what we will do, we will take a tan value. Okay, so tan theta, we know that it is cot 90 minus theta, right? Herein we know that what is in place of theta, it is 2a, right, is equals to cos 90 degrees minus 2a. We don't know the a value. Okay, that's all we need to find out, right? Okay, so this will be converted to this value, right? Tan 2a will be replaced with cot. So they both will be in the same terms. Nothing but, like tan 2a is nothing but cot 90 degrees minus 2a, right? We are replacing it is equals to, we are copying this value. We got in the same terms, the both things, both the sides are in same terms, cot and cot, right? You can even convert it to tan, again I'm saying that, but since it is having a complicated value of a minus 18 degrees, we are taking up tan value. Okay, 90 minus 2a is equal to this thing, and since they have the same ratio, what we can do is that we can just take these two angles and solve our problem since it's the same ratio. So 90 minus 2a is nothing but a minus 18 degrees, right? So what we will do, a terms one side, degrees term one side, right? So 90 degrees minus, since it's like the highest number and we can just get it here. 18 degrees when it comes at the minus 18, when it comes to the another side of the equation, it will be plus 18 degrees, which is equals to a is here itself, and this minus 2a, when it goes to the another side, it will be plus 2a. Okay, a terms one side and normal numerical terms one side. So 90 plus 18, it is 108 degrees. A plus 2a is nothing but 3a. It's nothing but 1a plus 2a is nothing but 3a. So since we need to find the angle A, we are keeping it angle A as it is and sending is 3 to the denominator. 108 divided by 3, which is nothing but 36 degrees. Answer. This is what we need to find out. Okay, the fourth one is, if tan A is equals to cot B, then prove that A plus B is equals to 90 degrees. Okay, so here in it's very simple. What we are doing, it is given, copying the given value, tan A is equals to cot B. Okay, here in what we can do, we can convert any of the value because nothing is given like the highest number or the lowest number. So we know that tan theta is equals to cot 90 degrees minus theta, right? So here in tan A, theta is replaced by A into which is equals to cot 90 degrees minus A. Okay, now what we will do, we will get both the things in the same term. So we are just replacing the tan A value with cot 90 degrees minus A. Okay, we just replace this value right here, which is equals to, we are copying this value, cot B. Sorry, cot B. Now it's very simple. Since we have the same ratios, we can directly compare their angles, right? So 90 degrees minus A is nothing but B. We're just taking up the angles here. Okay, and these two things will be cancelled. So 90 minus A is equals to B. 90 degrees is equal to getting all the numerical term one side and all the alphabetical term another side. So it's nothing but B. Since it's a minus, it goes on other side and gets a plus. It's nothing but A plus B. Either you write B plus A plus A, it's one and the same thing, is equals to 90 degrees. Did we prove it? Yes, we did. Yeah, and now we move on to the fifth problem. That is, if ABC are interior angles of a triangle ABC, then show that tan A plus B by 2 is equals to cot C by 2. See, in this problem, there is no need to worry. Basically, interior angle means it's nothing but the angle which we are dealing with. Okay. So we generally said, like during explanation of the formulas, I just said that A plus B plus C angles, these angles will be equal to 180 degrees. Did I say that? Yeah, I did. Next thing is that since it's not dealing with like 90 degrees or something, we will directly get in the conclusion, like we will be not taking directly B angle B as 90 degrees. It's given A plus B divided by 2 and C by 2 in that way, right? So what we are doing, multiplying and dividing both the sides by 2, right? Why are we doing by 2? Because seeing the question, seeing the demand of the question, we are making our answer. Always when there's something to prove, we need to adjust accordingly. So angle A plus angle B plus angle C divided by 2 is equals to 180 degrees divided by 2, right? So seeing this, seeing the question, what we are concluding is that, just remove the angle for the ease. What are we doing? See, this angle, A plus B plus C divided by 2, okay? I just take it as a rough work, which is equal to A by 2 plus B by 2 plus C by 2, right? It's nothing but the LCM, we are splitting it off. Okay, we can either, write anyways. A plus B divided by 2 plus C by 2. We can write either this way, or we can write a plus c by 2 plus b by 2, or we can write b plus c by 2 plus a by 2, right? We have so many options, but since the question is demanding a plus b divided by 2, we will be going with this option. We have so many options, right? Okay, we can write it singly, I mean individually, or we can just club these two or that two and write, or write overall same. Because our question is demanding a plus b by 2, we are taking this concept. Okay, so herein it's nothing but the explanation why we are taking this one. Herein a plus b plus c whole divided by 2 is nothing but 180 degrees by 2 is nothing but 90 degrees, right? So what are we converting this to? Here we got it. A plus b by 2 plus c by 2 is equals to 90 degrees. It depends on the question. This again I'm saying this this thing depends on the question what is given, right? So what are we doing now? We are keeping a plus b by 2 in this left side, and we are sending this c by 2 the other side. So a plus b by 2, which is equals to 90 degrees minus c by 2. Okay, we got this answer till here. Now, since like in a previous problem also we just said that any of the angle here, if it's same, we can equate that. So we will be, for the our ease, we can take any of the angle, but for our ease, we are taking tan on both sides. Okay, which is nothing but tan. Since it's given in the question that it is a tan and cot terms, we are taking tan on both the sides. Okay, so tan, we are just adding tan here, a plus b by 2, which is equals to tan 90 degrees by minus c by 2. Okay, when we are seeing this, isn't that seem very similar to this thing? Like cot theta is equals to tan 90 degrees minus theta, right? It is similar, right? So here in 90 is 90, theta is c by 2, right? So it is converted into this. Okay, tan a plus b by 2 is equals to tan 90 degrees minus c by 2, that we have got. But we know one thing is that seeing this 90 degrees and this thing, cot theta is nothing but tan 90 minus theta, right? So isn't it similar, something like 90 minus theta? This is taken as theta, right? So cot theta is nothing but here, according to the question, 90 degrees minus c by 2, right? So herein, instead of theta, there is c by 2, right? So cot c by 2 is nothing but tan 90 degrees minus c by 2. What are we doing here? We are replacing this tan value to cot c by 2 value, right? So tan a plus b divided by 2 is nothing but this whole value is changed to cot c by 2. Hence, proved. We proved the question. This sixth bit is damn simple. Express sine 75 degrees plus cos 65 degrees in terms of trigonometric ratio of angle between 0 degrees and 45 degrees. What it is saying that in the question, the angles angles of sine and cos is like more than 45 degrees, right? 75 and 65. We just need to convert them and express them in the angle ranging between 0 degrees and 45 degrees. That is simple. What is given we have? We don't need to even need to solve this problem. We just need to get the angles in the which range between 0 degrees to 45 degrees, but not more than that, or in between these two angles. Okay, so we know that sine theta is nothing but cos 90 minus theta, and cos theta is nothing but sine 90 minus theta. Okay, herein let's see. Okay, 90 minus 75 and 90 minus 65. What are we getting? 90 minus 75, it's 15. 90 minus 65, it is 25, right? Okay, are these values less than 45 degrees? Yes, of course, it is less than 45 degrees, right? So what are we doing? We just replacing these values with the lesser angles. So sine 75 is nothing but sine a cos 90 degrees minus 75 degrees plus sine 90 degrees minus 65 degrees, which gets converted to cos 90 minus 75 cos 15 degrees, and this cos got converted to sine, and sine 90 minus 65 is nothing but sine 25 degrees. Answer. It's not asking us to solve, it's just telling us to express in the angles ranging between 0 to 45 degrees, and we did it. 15 is less than 45, 25 is less than 45. So this is it. And if you like my channel, if you like my way of teaching, do subscribe. Just click the bell icon so that you don't miss any notification in future future updations. And do like, do share, do subscribe my channel. Have a nice day. Bye bye. Take care.